Hi everybody. So today we are starting the new unit for year 7 which is algebra, right? So before going through this lecture, I suggest you to go through the introduction lecture. You will get a whole idea what expression in this lecture can go in a very nice flow, right? So there you will have an idea that why we use variables, what are general terms, and here you'll be studying about solving equation, and that's what it is. So that lecture is designed very well. It act as a proper introduction, as well as it covers up all of your basics regarding algebra. So let's go ahead with this one, and here we are directly starting with simplifying expression, right? So that So I hope you can see my screen, and let's start with simplifying expressions, right? I hope you must be knowing about what are expressions, what are equations, and what we do. Okay, great. So let's go ahead and so there are some key terms before we go ahead, right? Those are that what are variables, what are terms, what are coefficient, mean, and how algebraic notation works, right? So I already told you in that lecture that variables are nothing but sum of the fill in the blanks which we represent as letter. So let's see. An algebraic expression is a combination of letters, numbers, right? And the letter known as variables stand for unknown or changeable. Suppose I write an expression like this: 3 plus something added gives me 7, right? So instead of writing fill in the blanks, I write x in place of that so that it is easier for me to represent. Remember, this variable is nothing but it is a number only. For now, which you are not knowing its value. So that is the reason why you have represent for your easy net with the help of a letter. Everything it will be following as number follows, right? It will be added like a number, it will be divided by like a number. That's it. But we have to see some things, right? That a variable can be added with variable only. Okay, so each individual part of an expression is called a term, right? Term can include just letters or mix of both. What I mean to say, suppose if I have 3x, this is a term. I have 3x square, this is also a term. I have 7 alone, this is also a term. Adding all of them, I make a equation, say 18. There are 1, 2, 3. So in except your operators, means plus, minus, multiply, divide, everything which is there in the expression are called terms, right? So here you can see AB it is combined, so this is one term. A minus B, I'll remove the operator. Without these operator, I have two things, A and B, so there are two terms. I remove the operator, plus and minus and plus. Without these operator, there are three things here, so there are three terms. Okay. Now, in algebra, we often use algebraic notation, which is simpler and more compact way of writing mathematical expressions, right? So this is how the notation. So everything you have to do it like your numbers only. What do I mean? Suppose when I write 4 plus 4 plus 4, right? Means I have taken 1, 2, 3, 4 added 3 times. So I can write this thing as 3 times I have taken 4, right? So what it is saying 3 times 4. So same way when I'll be doing y plus y plus y, I can write this thing as 3 times y, and this I write it shortly as 3y, right? So remember, AB here written means directly when they are written, we have a multiplication sign. AB is means A times B. 3 times y means 3 times I have taken y means y plus y added 3 times. A square is A times A. Also, I will strictly tell you this thing that y square, right? 3y square if you write, okay? This cannot be added to 3y. Remember, only like terms are added or subtracted. Okay, so you must be thinking that it is 3y times y, so I can add. No. Exactly same term should be there, only the front number should be different. That's it, then only it can be added. So here if it is y square, here if you have y, then only it can be added. Only front number should be different, exactly same term should be there. So a square you write it as a times a. 3a square is 3 times a times a. A cube is a times a times a. A square b is a times a times b. A by b is a divided by b. A coefficient is the number written in front of a variable in an expressions. For example, 5y is the number 5 is the coefficient, right? When coefficient are not whole numbers, they are expressed at fraction instead of decimals, right? So let's see how do we write it. 4, we have to write it as a single term. So we write 4 times p times 4 times p, right? 4 times 4 we write it as 16. P times p is 16 times p square. So we write it as 16p square. 2a times 3b. So 2 times 3 is 6 times a times b. K plus a. How many times? 4 times there are k. So I'll write it as 4k. This is how we can add the expressions, right? You have to use all the things which were given there. Simplifying expression. So you have to combine like terms. Like terms have the same variable power but may have numerical coefficient. Remember, I already told you 4y square and 4y are not like terms, so they cannot be added or subtracted. Multiply and divide is applicable. Addition and subtraction is only applicable for like terms, right? So you cannot add or subtract them. Definitely you can do this thing or you can divide. Let's see, simplify the expression 7w plus 5w minus 2w, right? So what I will do, 7w plus 5w will give me 12w minus 2w will give me 10w, right? So this is how it is done. 7 plus 5 minus 2. Since you can see w, the end part is same, only the number was different. So this is a 12 minus 10 is 10w. Simplify the expression 6a plus 2b minus 4a minus 8b. So a minus a, I will rewrite it as 6a minus 4a plus 2b minus 8b. 6a minus 4a is 2a. 2b minus 8b is minus 6. So 2a minus 6b. This is it, right? So you can write 6a and minus 4a are similar because they have contained the variable a. 2b and minus 8b are similar because they contain the both variable. Rearrange the group term 6a minus 4a, 2b minus 8b. So this is what you get. So the expression you get is 2a minus 6b, right? So this is what we have done. You will get the questions in the blogs as well as you will get the worksheets also that you can solve. Right. Thank you.